Okay, so we're going to be starting today. Welcome to getting into our notebook some more with 7.1. We're going to be talking about the second warm up. So the first warm up, I don't know how your homework worked out yesterday, but don't worry about 7.0. We'll grade that whatever it comes on that one. So we're starting with the 7.1 warm up, which should be on the first page of the notebook. I'm not 100% sure how the notebook lays out. I'm a little bit iffy on it. I haven't looked at it. So when I get back, we'll look. But anyway. Here is our press question. We're supposed to be finding the circumference and area for the circles below and compare the results carefully. So we've kind of got this little goofy table going on. And so we've got the radius of 1, which is this first one, has an area of 1 pi meters squared. So what I used was, of course, the pi r squared formula for area. And then the circumference is going to be c equals 2 pi r. So my circumference is going to be 2 pi meters. And so that's the first one. Go ahead and do the other two, and then we'll answer the last question together. Make sure you pause. So I hope you paused your video. I'm sorry that I was so abrupt right there, but pausing your video. This one is going to be 4 pi meters squared, and the circumference is the same. Again, the reason units are so important, this is going to be 9 pi meters squared, and this will be 6 pi meters. And so how do they compare? Well, what I find interesting is that the one with a radius of 2, this area and circumference are very similar. They're both 12-ish units, but one of them is meters and one of them is meters squared. And if you recall our conversation about the difference between units and why they're so important and what an inch looks like or a meter looks like, where it's a piece of a line. So this is what a meter looks like. It's just this thin line. And whereas the area is a square and that's why we have square units and the volume is cubic units. So it's very important that you use the right units. But notice that the area grows faster but starts smaller. The circumference is growing at a linear rate of adding 2 every time. And of course the area is growing at a quadratic rate. So something like that for your comparison, whatever works for you, make sure you fill that out. You might want to pause the video so you have time to do so. We're going to start with 7.1 notes today. It looks like I've cut off the bottom part of this paper, so we'll move it up in just a second. Here's a drawing on graph paper in which a rotation of a figure is shown. So we've got figure A was rotated to create figure A1. So it was not translated up to and left for. It was not reflected across the line. It was rotated. And our goal is to figure out where the center of rotation is located. So someone has challenged us to do this. And this person is the person they mentioned at the bottom. So we've got student 1 who says, hey, I think the center of rotation is 2, 4, which is halfway in between the 2 points, and that it rotated 180 degrees. Okay. And that seems very reasonable because there it is right in the middle, and that would work, I think, maybe, who knows. Student number 2 says, I think the center of rotation is at the point 0, 0. Since both the image and the pre-image are 5 units away. So that's clearly 5. That's clearly 5. When I move my finger, you can't see. That's clearly 5. This is a little trickier of a 5, but it's 4 this way and 3 that way. So 3, 4, 5. Yeah, they're both 5 units away, so that seems reasonable. They're equidistant from the center of rotation, and I'm going to need a protractor to figure out the angle, but hey, I could do that. This is what I think is happening. The person who created the drawing tells them that neither of them is correct because they did not use either of the points for the drawing. So this is what we have going on here. So if you haven't already, make sure you plot student 1 and student 2. I'm going to go ahead and label this S1 for student 2, excuse me, and this one S1 for student 1 so that I can tell them apart in a minute. I'm going to continue on. Student 3, another student, not one who created the puzzle, says, I can see how both of the first 2 students' points can be the center of rotation. But now I think that with a single image, pre-image pair of points, any point can be a center of rotation. So that's an interesting thing. He's saying, yeah, they could both be right. And didn't we basically verify student 1 looks right, and he is. It makes complete sense. It's equidistant, 180 degrees. It's really obvious. Whereas this one's a little bit more tricky, but you're like, okay, I could put some patty paper there and rotate that onto that. I'm just going to do some quick rotation moves for you. So we've got our center of rotation, and I'm going to draw in with green my first dot at A, and I'm going to rotate it around this dot here. And so notice how it passes through S, and it totally lands on A. Now, I don't know how much it rotated, but it totally landed there, so it seems really reasonable that he's right. And we can do the same thing if we move our center of rotation here to student 1's conjecture, that it's going to end up, I went the wrong way, but it's going to end up right there. So that's 180 degrees, and it ends up in the right place. And yeah, he's correct too. And so we've got all these things that are happening here, which is a very interesting set of things. Why that's happening. Okay. Nope. I'm done. So anyway, can we find some more points? So what I want you to do is pause the video and see if you can find me some more points. I'm going to find some points too, but I'd love it if you could come up with a few. So go ahead and pause. So I hope you found some. I found several. The justifying your choices, how you would do that is to use patty paper to see if you're right. Or do what they did, what student 1 and student 2 did, where they listed a risk. Now, I'm not going to justify my choices, but these are the ones I found, the ones in black here. So I've got 1,2, and I think that's a 90-degree rotation. I've got 3,6, which I also think is 90-degree rotation. I have 4,8, which I think is the same rotation as student 2's would have been. I can also have 5,10. I don't know what the angle is there. I've got 1, -2, and so on. So all of those points. So any point, by the way, that you chose that is on that set, you're good. There's a lot. So do we agree or disagree that any point can be a center of rotation? So just with that in mind, I'm going to pick another point, which I'm going to call, and I'm just going to put it right here and make that the center of rotation. What do you think? You think it'll work? Because any point will work. And so let's see what happens. I'm spinning it around. Do I ever get close to A prime? And I don't. So what do these points that I found actually have in common? Because student 3's anyone will work is not. I disagree. So if you agree, explain. And I'm going to disagree. What statement works better? So I want you to look at these dots that I have that work, that are the black dots, and tell me what you notice. Think about it for just a minute. What I notice is that they form a line, which is how I found them. And I want you to think about that line for a minute. So that line turns out to be the line of reflection if I reflected A onto A prime. And any point on the line of reflection can be a center of rotation from one point onto the other. It's pretty dang cool. So this is what I would say. Any point on the line of reflection for a single rotated point in its pre-image R can be. It has to be on the line of reflection, but they will all work. And so something like that is what you need to be writing here. I'm not sure what you've written down, but make sure you take some time to make sure you understand what we just talked about, because it's about to get really tricky in the next video. Good luck.